Welcome, my little break monkeys. I hope you're enjoying your quarantine. Today we're going to do a quick little video on some Pcode internals for Visual Basic 6. This also applies to VB8. So today we're going to be looking at for loops, and I'm kind of going through and documenting the different opcodes. There's about 1,000 of them, and they come in multiple flavors. So here we're going to start with our inner loop here. So we have a counter variable b, which is a byte, and we're going to start at hex 22, we're going to end at hex 26, and we're going to step at an increment of 2. And we want to see what the Pcode output looks like when this is compiled to Pcode. So we've gone ahead and we've already disassembled this. This is the vbdec Pcode disassembler / debugger. That's not public yet, but you guys get to follow along and watch it in action a little bit. So we've set a breakpoint here. We're looking at our inner loop. Here we can see that they come in multiple flavors. We have the for each variant. We have for each array variant. It's stepping over an array. Here we have the for-step UI1, which is unsigned integer 1, which is a byte value. And so what we'll do is I'm going to hit F5. We are starting our debugging. I'll hit F5 again, get to our breakpoint. All right, so up here we see our stack pane, and down here we see our hex memory dump. So I'm going to hit F7, and we're going to step through these now. Byte value 34 is our hex 22, and this is the literal I2, so it's pushing the 2-byte integer onto the stack. So up here we should see a 2-byte value get pushed on, and I'll actually put it into 32-bit mode for the stack there. So we can see that 22 was indeed pushed. Our stack grew. We see one push up here. Now it's going to be converted from integer 2 to an unsigned byte 1, so a byte value. It's basically, that's just bounds checking, I believe. I got to look at it a little bit closer, but I think that just throws an error if it's outside of bounds. This one is going to load a reference variable with var9a. Now this, or the address of var9a, actually. And we can mouse over and see, I don't know if you can see the mouse over tooltips, but it's showing it's currently 0. And we'll watch our stack change again. And here we can see that, turns blue. This is a value that's pushed on. We can see it's EBP minus 9a. So there's our second argument. We've now had 2 things pushed to the stack. Now we're going to load our next byte value, which is our end of loop counter. Do the bounds check, and now this is going to be our increment that gets added, and then bounds checked. So what we can see is we're preparing for our 4-step loop here, as denoted by the indentation. We have 4 stack arguments that have been pushed on, which are, loop start, adjustive counter, loop end value, and then step increment. Now, we also see that this 4-step UI1 has some arguments to it as well. And if we look at the byte stream here, so these 2 are the opcode bytes, and that's actually the table, the lead index, and then this is the opcode into that index. And then these next 2 have been decoded as, this is the variable of basically a loop control structure. And, that's the var E4. And if we look at var E4 down here right now, it's 0 still. And we can mouse over that too if you can see it. So that hasn't been initialized yet, but that's where the loop control structure is going to be saved. And then we can see that this address here, this 8300 has been decoded as, a jump address. And that jump address is actually the end of loop address. So when the conditions are met, that is the address that it goes to exit the loop. All right. And the way that this is calculated actually is, so you got to remember this is like the little endian format. So this 8300 is actually 0083. And if we were to calculate from our function start, if we were to add OX83 to that, that's where we get our end of loop address. It would be the 16B3. And again, I mean, all of this has to be reverse engineered and figured out. Like, I'm telling you what it is because I've figured it out. But yeah, this isn't documented. And part of the joys of creating, I mean, this is like a giant nerd toy, really. Creating your own debugger for an undocumented Pcode specification, being able to control it, being able to watch it, being able to watch the stack grow as these different things happen. All right, so now we're about to execute our 4-step UI1, and we're going to see that these 4 arguments on the stack get consumed. But we should have our stack reset to the EC as soon as this runs, and we should see something happen to our E4 variable. So I'm going to single step it. Here we go. All of those were consumed off the stack. They're all popped. We're back to the EC. It didn't push anything onto the stack of its own. Now, our var E4, if we look, we can see it turned red and then it changed. Anything that got changed in the stack has turned red. And the loop control structure is actually, we can look at it in the 32 or the 16-bit mode. This actually looks like it's going to be a structure, is this var E4. It looks like it's going to be a structure address. And if we look at this down into the memory pane, which I already got down there because the last time, we can see the memory layout is 0226. And this looks like a structure size, 2 bytes. And then 26 is our end of loop variable. And so this control structure will be used in our next step. It determines where's our current counter value and whatever. So, or actually, you know what? That's step increment, actually, and final address or final value. That makes more sense. Figuring out as I go. All right, so load UI1 from var 9a. So if we look at 9a, our current value is 22, which, well, I don't know if you can see those. Let's see, 9a, there we go. And we can see that it also initialized, that turned red as well. And that was our initial value, the 4-step UI set, the var 9a. And that, again, that's how it knew, it was one of the arguments of them. So we'll do an F7, and we can see that our value has been loaded up here. It loaded to the top, pushed it onto the top of the stack. Bound check. Now this literal byte is going to push another byte onto the stack of a value 4. And if we go back to our source real quick, you can see inside of our loop we have, if our counter variable is equal to 4, then exit our for loop. So now we're going to do an equality operation for 2 bytes worth size for an integer. And it consumed 2 fizz off the stack and pushed a value of 0 onto the stack. So we can see there was 1 pop and 1 mod, which in reality was 2 pops and 1 push. But I can't discern that from my current logic because I'm kind of looking at things after the fact. Now we're going to do a branch if false, and that's going to take a look at this top stack argument, and then it's going to jump to this address right here if it's false. So 0 in Visual Basic 6, -1 is true. So it's actually going to branch right now. So it jumped over that, and it popped that value off of the stack. Now we have our load reference variant or variable, 9a again. And again, this is our counter variable, and we'll see it. So now we have the address of 9a put up here onto the stack. And again, that's our counter variable. So we can see that this next step, UI1, takes 1 stack argument, which is the address of the counter variable. And if we look at the 9a Where are you? There. Oh, yeah. Gotta go back to 16-bit. 9a is 22. So when we do this step, that 9a is going to increment. Brain farts here, left and right. Here we go. 9a. Now we see that it turned red and our value is 24 because our step increment is 2. And we can see that our E4 has not changed. And again, that's our step and final count number. And we're ready to repeat our loop again. So, yeah, these for loops come in multiple different flavors. You know, we have our for each, which takes a different set of args. We have our, so this one would be an integer, or actually a long, because it's a 4-byte. In V6, an integer is 2, a byte is 1, a long is 4 bytes. And then the one doesn't have a step increment. So this one, we can see, just had the 2 values. It actually took the 3 arguments. It took start, counter, address, reference, and then the end. But our for loop is still the same here. And then this one, we can see, actually took more arguments. And we can see that there's 3 decoded up here. And somewhere, if I didn't close it, which apparently I did, so I won't be able to show you that right away. There's a whole bunch of different variants of these for loops in terms of their bytecode offsets and stuff and how many arguments they take and everything. So I've been going through, and I have to understand this because I'm writing a debugger and disassembler for it. You know, it's an interesting thing. I've been going through, I want to document the whole opcode set, to tell you the truth, because I'm a nerd like that, and I enjoy it. And also there's some kind of fun stuff that you can do with it too, but I'm not going to get into it for all the miscreants out there. Anyway, so I thought I'd share this little video going through and how to understand you know, Visual Basic 6 Pcode. It's not really documented. It's not really talked about. People generally don't have good tools to work with this. So, you know, we have our byte stream arguments. We have our byte dim arguments that the instruction takes, and then we have our stack arguments that the opcode will take. And I guess that's it. Probably got everything I wanted to say. So, I don't know how many people actually give a crap about this. You know, it's a very not mainstream thing we're doing here, but I find it quite interesting and to figure out. I mean, because you get to prove it, right? Like you have a theory, and then you get to now we get to watch it in action with a debugger. I had to create all this, and I don't know. It just would have been great if they had released the spec on this stuff like they did for .NET. And again, this also will apply to understanding VBA Pcode if you are ever so cursed. All right, I'll stop babbling. Enjoy, guys. And if you give a shit about this, if you want to see more of these videos, let me know down in the comments, because if nobody cares, then I'm not going to bother doing this. Except for my own, I'll just keep it private. Fuck it.